I love a good restoration, but this one was in a class of its own. I came across this thing at a vintage computer festival, and I almost didn't pick it up due to the shape it was in, even though I had been looking for this exact model of IBM ThinkPad for a very, very long time. As you can see, it was in incredibly rough shape. It had obvious drop damage and who knows what else. I had to pull out my entire bag of tricks on this one. The batteries, the bezel, the screen, the circuit boards, and let's talk about the screen for a second. Because this screen does not exist anymore. They stopped manufacturing this specific pen-based display decades ago, even though it actually has some components that you would recognize today. Nobody had one. So I had to get a little creative. If you know me, you know I love going deep on these things, and this is absolutely no exception. As we go through restoring this thing to its former glory, if you like what you see, please like and subscribe. It really does help small channels like mine reach a larger audience. Also a big help, PCBWay, a channel sponsor, and we'll talk about them in a bit, but for now, let's start at the beginning. When I picked this up from the original owner, he had said that it was working before it was dropped, but that there were definitely some issues, so I decided to plug it in, power it on, and see where we got. The LCD is definitely dead, but you can see the backlight turns on, and when I use the pen, I can actually see things happening underneath this kind of corroded layer. The next thing to do is take it apart and look at the system board. We're looking for signs of cracked PCBs, we're looking for signs of corrosion due to leaking capacitors, pretty much any kind of damage that we can see visually. Right up top, we've got our VGA controller and our system controller for our 486 CPU. And up here, we've got our two Wacom digitizer ICs. They're the ones that control the pen input from the back of the LCD screen. I'm going to need to completely disassemble this LCD enclosure, so right now I'm just going to disconnect it from the laptop and set it aside. Most LCD screens are actually a sandwich of a ton of different layers and components, so I need to take this thing apart and see what's inside. My hope is that I can take the cracked LCD panel itself and replace it with a new one. Usually you can't do this because none of them are really the same size across manufacturers or models, but I've got an idea that I think might be able to work. We're also going to need to take care of the front panel glass where it looks like the paper-like coating has corroded over time. The very first thing I did was go on a hunt for a new panel. I narrowed down my search looking for specific characteristics. It needed to be 9.4 inches, monochrome. It also needed to be dual scan, meaning there are PCBs for the column drivers on both the top and the bottom that would fit into the case. It needed to have a similar power profile. It needed to be transflective. All of these attributes really narrowed down my search. This is the second one that I ended up purchasing, and after taking some measurements, it is really, really close. The PCB layout is actually identical, as well as the size of the panel. The type and location of components, including the connector, are very different, which looks like it's going to be an issue with this case. The top of the LCD case, however, looks like it's a perfect fit. Now, I had anticipated this, so my plan is to recreate and 3D print a new bottom of the LCD enclosure to make sure everything fits. In order to do that, I need to separate the bottom of the case from the Wacom digitizer, as well as the backlight and the rest of the components. I'll be removing all of the glues, really stripping this thing down bare bones, and then reapplying everything new afterwards. The digitizer is super cool. It actually creates an electromagnetic field that can then track the location and the pressure of the pen on any part of the display itself or within the magnetic field. This also means that the pen itself gets power from that electromagnetic field and doesn't need a battery or anything else. Keep in mind, this is technology from 1993. This tape was incredibly sticky, so I used some denatured mineral spirits to break up the adhesive, and then a plastic razor blade in order to scrape up the rest, making sure not to damage the PCB underneath. When I look at modeling something, I always want to make sure I know what I want to change. So the real piece that's an issue right here is this front part. So the front part, one blocks the center edge connector, and it also sits on top of some of the capacitors on the other side. So this is the part that I'm going to need to change. I also need to make sure when I'm modeling this, I take everything into account. There's divots over here where the digitizer sits, and there's a lot of other pieces that need to be just right. The good news is it looks like this thing barely fits on my build plate, so I won't need to print it in multiple pieces. Now, when you're modeling something that you want to fix, there's a couple of approaches that you can take. The first is to only model the pieces that you need to graft on or modify the part itself. So I could have gone back and just cut out that front piece, and then what I'd be left with is kind of a gap that I would need to 3D print and graft on a piece that would fit that front piece. That's generally not how I like to work, especially with doing something that's old, something that's vintage, because I think that people might want this model to be able to completely reprint the original bottom piece of the case itself. So what I do is I actually model the entire thing as it stands. So you can see that this is a replica, a complete replica of what it was before. Then what I do is I compare it with the original, and then if I need to, go back and make small adjustments to get it to fit. So the purpose of this right here is really just to make sure that I have modeled an exact replica of the bottom case. So I've got a model that I can use now if anybody has a cracked display and needs to print this off again. I know it's not likely, but I've got it anyway. Now I can go back in and make it fit the new display. So I'm cutting off the pieces that are interfering with the capacitors here. I'm kind of making it one solid bar. And now I'm going to go back and I'm going to make a similar cutout for the center display connector to live. So it won't be interfering with the capacitors on the left. And I'm making a cutout here. So hopefully it'll then fit the display. When I restore something like this, I don't just want to slap everything back together. I want to take time to get everything right, whether it's the glue, the glass, the plastics, or even these small, thin, padded rubber strips that protect the different layers of the display. I found this 3D printed tool, and along with a razor blade, allows you to cut really precise width, long strips. Now, I'm pretty sure it's for balsa wood for model makers, but it makes some quick work of these little rubbery foam strips that I needed for the inside of the display. I'm not a fan of single-use tools, but one, this was 3D printed, and two, it also does really well on really thin strips of tape that I'll need later on in the project. The next step is to affix the digitizer to the back, and it's really important to get the measurements right here because the digitizer, while you can configure it, is the thing that tracks the pen around the screen. So if it's off significantly at all, where you place your pen is not where the cursor is going to display. After the back panel is in, we'll replace the backlight, the diffusion layers, and reroute these wires. As I'm removing the glass from the front, I'm seeing that it is actually glass, and that was common back in the day. Laptop manufacturers used glass because, at the time, polycarbonates were a lot lower clarity, and they scratched a lot easier. I'm really taking my time to remove this glass carefully, not because I don't want to crack it, I've already done so. It's more of just I don't want to shatter it and risk cutting myself. One thing to point out is that these glues are incredibly tough. They are definitely not made to be reversible, so I take my time to make sure I get every little last piece off of the plastics. I'm taking some final measurements so that I can put in a new panel that'll fit perfectly. Now, I am going to be using a polycarbonate, or specifically a Lexan. The reason is that it's incredibly tough, incredibly durable, and I'm not worried about the scratchability of it because I'm actually going to be putting on a paper-like screen protector on the front. This does a few things. One, this allows the display or the screen itself to be protected from scratching when you're actually using a pen. And two, it gives a really nice matte finish so that it's not reflective, because as you can see, this polycarbonate is pretty reflective stuff. I'm loving my little strip cutter. This thing is perfect for tape. What I do is I take this double stick tape and I put it on top of a piece of masking tape that has a waxy coating on the outside, so it sticks a little bit but not too much. It allows me to cut these really, really thin strips and then use them on the sides of the display where I want to reinstall the glass. I'm really happy with the finished product of how the glass came out. You can tell that it's got a really nice matte finish, it's not reflective, and it's got that paper-like texture that the original screen had. So all in all, this was a really successful part of the restoration. Now that we've got the new back of an assembly that fits the new LCD and the front fits as well, we need to look at the connector. The connector is different from what it was on the old display. Now, the connector is actually the same on the side of the computer than it is on the new LCD, so I need to confirm the pinout. The good news is that this should just be a pretty straight swap. I plan on using the same cable as the old one, and so what I'm doing is I'm carefully removing the pins on the old connector. Now, I'm not going to be able to reuse those pins because the size of the pins on the new Molex connector is a lot smaller. I need to make sure I get the orientation right, so after I've plugged everything into the new Molex connector, I need to check the continuity, which means that I'm going wire by wire to make sure that nothing is bridged, there's no wires that are contacting more than one, and that every wire I think is going into the other receptacle is the right one. The next is the test on the tablet itself. I plug both sides in, but instead of using continuity between wires, I'm using it on the back of the terminal to make sure that the wires inside the connector are all making contact. Now, I'm being very, very careful about this because if you send a higher voltage into a pin that's not expecting it, you can really damage the LCD, and I don't want to go through that process again. So now with the brand new display and the brand new casing with the brand new glass, we power it up and see how it looks. The backlight comes on, which is a good thing, but unfortunately, it's incredibly hard to read only at a certain angle. The pen works, so that means the digitizer is working and aligned, but we're really going to need to figure out what's going on with that screen. That contrast and angle issue could mean a few things, and so I'm going to start ticking off boxes. The first thing is the polarizing layer. I want to make sure I'm using the one from the new LCD and not the old one to make sure the light is coming through. The second is that I want to recap the display. So there are some electrolytic capacitors on this display that I'm going to be replacing with solid polymer capacitors to make sure that they don't leak, they don't corrode, and they don't cause any issues long term. If you've ever recapped a display before, you know what a difference it can make in both brightness and clarity. I chose these polymer capacitors carefully because I didn't want the size profile to be that drastically different, and then I'd have to modify the bezel again. You're going to see this reinforced throughout everything, but I've learned along the way to always check. I'm checking the continuity to make sure that I'm not plugging anything in that'll destroy just a ton of hard work. The new LCD was supposed to be new old stock, but after being in it for a bit, I could definitely tell that there were signs of use, and removing the CCFL backlight tube confirmed my suspicions. Some components degrade over time regardless of if you're using them, but not these tubes. This black end right here shows that this tube has seen significant use. Luckily, these things are still cheap and plentiful, so ordering a new one at the exact size that I need is no big deal. I just need to disconnect the old one and solder on the new. A little trick when replacing these is to solder on one end, then pull it through the loop, then solder on the other. That way you don't actually have to cut any of the paper or modify the backlight plane. So after reattaching the rubber caps onto the tube and getting everything put back together, this thing should light up like it's brand new. So at this point, the only thing I can do is start it up, cross my fingers, and while the backlight does turn on and is significantly brighter, it still has the same issue. And that's when I realized that this wasn't actually a problem at all. I just didn't have the contrast turned up correctly. So what I do is I take the original bezel so I know where the pen input is, and when I adjust the contrast, the screen, well, the screen looks great. And now, with all the display issues behind us, we can focus on the system board. Going into this, we know a few things. We know the display works, we know the digitizer works, and we know the BIOS works because we were able to play around with some settings in there. Being this old, we can almost guarantee that there are at least two issues, one with the sleep battery and the other with the CMOS battery, both of them which we're going to need to replace. We also haven't yet tried to boot an operating system, so there could be more memory issues as well. But for now, taking a look at the board, it looks like we don't have any audio hardware, but we do have a PC speaker. We also see our i486 33MHz CPU and our coin cell battery that's soldered to the board. The sleep battery is a little more accessible by using this connector right here, but holy cow IBM, did we really need instructions on not throwing this into a fire in 20 different languages? The white kind of dust that you're seeing is most likely a magnesium oxide. It's oxidation that happens when air or water is exposed to the metal. Now, keep in mind this is a magnesium alloy, otherwise this case would have detonated by now. I will want to clean it up and reseal it for aesthetic purposes, but it's not really harmful. Continuing on, we need to disassemble some of the display bezel. These light pipes are the ones that actually take the LEDs and make them shine through, and this blue plastic piece right here is really just the backing piece to those blue buttons that you saw earlier. You can tell this is an original IBM because the badges were always made of metal back in the day, and so they're really easy to clean and really easy to flatten out, which is good for me. We'll put these pieces aside and continue on. Look, I know that I could have repaired the bezel rather than completely modeling and 3D printing a new one, but there's going to be some instances where somebody has a bezel that they can't repair, and 3D modeling or printing or sending it to a manufacturer is going to be the only case, so I like to create these models. And when I'm creating something this large, I like to do it in pieces. That way I can check the dimensions and the fit without having to completely reprint an entirely new model. I'll go through multiple rounds of printing and checking and printing and checking before finally doing the full piece. The bezel was too big for the plate, so I had to print it in two pieces. This is not a terrible thing because I had been planned on sanding this thing down and painting it anyway, and so there's lots of opportunities in order to sand out any imperfections, and especially within the joins. I added ridges in these two plates that I'll put in to help line it while I'm gluing it all together. I'm using this black JB Weld epoxy to fit the two pieces together. After I apply it, give it about 20 or 30 minutes, it cures enough in order for me to be able to sand it and continue on with the rest of the paint job. When I paint something that's done on my filament printer, there's a few steps that I take. The first is to sand out any imperfections on the original, knowing that there's going to be a ton of layer lines. I'm not trying to get rid of those right now. There's also going to be defects in the actual print. After that, I use a thick sandable primer and get everything as smooth as possible. Once it's primed, it's a lot easier to see any large gaps, which I then come in with a Bondo putty in order to fill. I'm not shy with this stuff, especially around the corners where most 3D printers will have trouble depending on the orientation it's printed in. You can always sand it down. In this shot, you can see the bottom print, the sandable primer, and all of the gaps that we were able to fill with the putty. Final step before painting is to push in these heat-set threaded inserts for 3mm screws that'll attach the bezel to the top case. The first paint job turned out okay, but there's definitely some issues that I wanted to correct, so I'll do another pass of sanding and painting as well. So let's be honest, just because you have a model, it doesn't mean it's really easy to print. It can be really, really tough, and that's where our sponsor comes in. PCBWay.com does all of this for you. You can upload a model, pick your materials, your surface finishes, even the labels that you would like screen printed on. I will often do a prototype in-house, but if I want multiple things printed, I will use PCBWay.com because quite honestly, it is a load of work as you've seen in this video. So again, if you don't have a 3D printer, or if you don't want to take the time or buy the materials in order to do something like this, using a third-party service provider like PCBWay is the way to go. And with that, let's get back to the video. Restoring labels is always different. Now this one might look pretty rough and cracked, but if you look closely, it's really only the top adhesive film that's the issue. I'm using my heat gun along with some other tools in order to peel off that protective film. I'm using solvent in order to take off the adhesive on the back, and as I work on this, you can see that it actually turns out pretty good on the bottom. I'll make sure to add a new layer of protective film on top before it's all said and done, but this thing turned out pretty good. I finish removing the other pieces of the case, and then we're ready to strip it. There are a lot of ways to strip paint from a case, but this one had some unique challenges. Because of the rubberized coating, I couldn't sandblast it. The company that I went to wouldn't do it because it would contaminate the media that they used, so literally, it was all acetone and elbow grease. I put these little things on the metal pegs because I don't want to paint the pegs, but I do want to make sure I get around behind them. I also mask off those labels that we restored on back and get this thing ready for a paint job. My process for recreating decals is a pretty straightforward one. I've started using a flatbed scanner. As any type of camera, there's going to be distortions within the lens, but with a flatbed, you get the actual kind of dimensionality of the logos that you want. I also need to measure the true size of the labels so that when I move them into my software, I can recreate the exact size that's needed, so I can send a 1-to-1 scale version to the printers to actually get them printed out. I'll use these translucent gray boxes in a couple of different ways. One to make sure that the image is flat, and then the second to confirm the size of a set of icons so I know exactly how big I should be making them. Then it's really just about going through with my vector tools and making shapes, combining them in order to form the different icons. When it comes to most of these fonts, I've done enough of these to know that IBM really only used about 3 or 4 typefaces and these kinds of icons, so I don't have to loop through about 1,000 of them until I find the right one. The type of technology used to put logos onto these parts at the time was most likely screen printing, as laser really wasn't common, but it's interesting, as you get closer in, you can see that they're not really exact. All of them are a little bit different, they're a little bit distorted, and so some of these logos are actually going to be a little bit cleaner than the original. Part of me wonders if I should be recreating these logos with the distortions and all, but I always end up doing it nice and crisp. Once I have all of the logos recreated, I put them all into a sheet in different sets, and I always do multiple sets because printing these in dry transfers is an incredibly expensive process. One 8x10 sheet could run you about $150 US. I take a piece of painter's tape to help me align it correctly, and then, using a plastic spudger or wooden tool, I burnish it down onto the surface. Wherever I can, I make the icons in sets so that when they're printed out, they're already spaced and aligned appropriately. It makes it a lot easier for aligning icons over large surfaces. And with everything painted and the icons applied, it's really starting to come together. To finish off the case, we just need to install the badge, that blue panel in back, and the light pipes. I really love the fact that this blue panel aren't actually buttons. They're just located in a very specific location to where that digitizer at the back of the screen knows to use those as buttons. It's such a cool piece of engineering to me. Even as I'm trimming off the first lead here, I know that this is a bad idea. You can see that I actually scraped the PCB underneath. I should have just desoldered it, but I don't know what I was thinking. Maybe I was rushing, because, you know, that happens. The good news is there was no damage, and I was able to get the pins out, get everything desoldered, get it cleaned up, and I was able to find a through-hole battery holder for the 2032 battery that we need. Now, when you're replacing these kind of batteries, you need to know if it's rechargeable or not, because you can put a rechargeable battery in a non-rechargeable circuit and that'll just be fine, but you cannot do it the other way around, otherwise it'll damage your battery and possibly cause a fire. When replacing batteries, you need to make sure to match the chemistry, and this is a nickel-cadmium battery, which are pretty rare these days. Now, luckily, I was able to find one for RC car controller that was pretty much an exact match. Always be careful to make sure that the red and black leads are the same on the connector as well, otherwise you could have a bad time. As I'm putting everything back in the case, I'm making sure that everything is seated correctly. I'm putting some heat-resistant Kapton tape in a couple of places that seem a little loose. I want to make sure that everything is perfect because I don't want to have to keep taking this thing apart. Replacing this shield and getting everything put back together makes it feel like we're really, really close, and this thing is looking fantastic. But we're not done yet. This is a tablet, and one thing that a tablet needs is batteries. Luckily, when I picked this up, it had one inside. Now, it didn't work and it started to crack open based on expansion of the cells, but I'm going to continue to open this up and make sure I know everything that's in there. Even though I know the voltage and the chemistry, I need to open this up. Some batteries at this time had ICs or chips inside that communicated with the battery management system and would prevent them from charging if they weren't there. Now, luckily, this isn't one of those, and it's really straightforward, but I had to confirm. To make my new pack, I'm going to be spot welding together 6 nickel metal hydride cells, which are actually an equivalent chemistry to nickel cadmium. The reason that you can't use different chemistries is because the battery management IC inside the tablet is going to be expecting a certain type of voltage drop when it discharges, which is how it tells if it's full or empty. I've got my spot welder dialed in to the thickness of the tin strips and knowing that I'm going to be welding to battery terminals, so I'm good to go. This is also the part where I tell you that you should not be doing this if you're not experienced and have taken appropriate safety measures. As I'm doing this, I'm constantly checking the heat of the batteries and the voltage levels to make sure that the connections that I'm making are resulting in what I expect. So at the end, I'll have 6 1.2 volt cells in series. I'll then solder on a couple leads to make sure I can connect them to the terminals. I didn't see any chips in the battery, but I did see a thermistor. It was an NTC, or negative temperature coefficient thermistor, which essentially means that as the temperature increases, the resistance decreases. I need to make a small voltage divider circuit because battery management systems typically don't read resistance, they only deal off of voltage changes. So when the temperature changes, this white wire will read a voltage change back to the battery management system. For the new battery cases, I modeled and printed some new ones. I've made sure to allow for all of the things that I need to actually put inside, including the 6-cell pack and all of the other wires that need to connect in all the terminals. Now, I fashioned some new terminals based on some tin strips that I use for the batteries. I'll scuff them up and super glue them into place. I'm not relying on this super glue because I've designed the case to actually support the terminals. This spray is a lifesaver. It's called a kicker, which rapidly accelerates the curing of superglue. While I have built in some clips, these cases really aren't meant to be opened and serviced, and so I'll make sure I wire everything up, get everything soldered, and then I'll put down some double-sided tape to keep the thermistor in the right place while I close up the case. I'll do a final voltage check on the main terminals as well as the thermistor, which should be about half. And after that, I'll make one more and we're ready to go. Powering it up, we see both battery indicator lights flash up immediately, and this thing is running on its own power. I'd call that a success. We've gotten all the main parts done, so now it's time for the final touches. This pen has been crushed, and you can see the plastic is strained and also a little bit collapsed. By taking a lighter, we can heat up the plastic, which brings all of the oils back to the surface and really minimizes that kind of white discoloration. It's not perfect, but it's quick and effective. There were a couple of broken pieces that I needed to remodel, one being this pen holder. I modeled it so I could reuse the spring mechanism. It makes it really easy to lock the pen into place when you put it in, and then easily be able to take it out by putting in a little bit of pressure. The tablet didn't come with a top port cover, and I actually wasn't able to find any reference pictures online, so I just took a swing at it, and it looks pretty good. It'll do for now until I'm able to make a full reproduction based on an actual cover. As I'm putting everything together, I'm making notes of areas that I need to come back and touch up with paint or reseal, but I'm pretty happy with how everything came out. With everything back together, I was able to reinstall the original operating system. Earlier models of this tablet came with Pen OS or Pen Point, but this one shipped with Microsoft Windows for Pen Computing version 1. I didn't have enough time in order to get pen support for DOS running, so I wasn't able to play Doom, but I do know that PC-DOS's later versions do have pen support. All in all, I'm super happy with how this turned out, and now I can spend some time exploring one of these original ThinkPads. One thing to acknowledge here is that I could have taken different avenues for each of these things. For the back of that LCD enclosure, I could have just modified the original ones and cut out the pieces in order to make the connector and the capacitors fit correctly. What I could have done on the bezel is I could have just repaired it, with some epoxy. I had some of the broken pieces, enough to be able to reconstruct it, and just given it kind of the same paint and label treatment. But honestly, that's not what I like to do. This isn't just about bringing a machine back to a workable or nice looking condition. This is about learning new tactics along the way, getting better at the skills that I have. So when I go deep and I want to completely remodel things, even though that's probably not what a normal person would do, that's why I've gotten into this hobby and that's why I love it. So let's recap. How did this turn out? Well, the batteries came out fantastic because they turned out to be dumb batteries, meaning they didn't have a lot of circuits and chips and logic inside that we needed to fix or recreate. They came out great. I couldn't be happier with the LCD and the fact that the second LCD that I bought was workable and we got it to fit within that package. The screen is bright, it's crisp, everything works great, so I couldn't be happier with that. The paint job came out great, as did the labels. Now, I've done the labels before in other restorations, so I kind of knew how those were going to turn out, and they did not disappoint. The other great thing is that aside from all of the cosmetic damage and the things that we had to do to take care of the display and the batteries on the circuit board, this thing was actually in pretty great shape. The logic board itself didn't need a ton of work. Now, I could go back and recap the power areas of the board and the inverter for the LCD, but that's something I can do in a future date. This thing is great just the way it is. The one thing that I would have liked to do is have the dock or the port replicator so that I could plug in a keyboard and play around with the BIOS a little bit more, or plug in a disk drive. There are some operating systems, specifically Pen OS, that used to ship with the early models of these that I couldn't do in an emulator and just copy it onto a hard drive in here. You need the actual physical disks because they need to be installed with a pen, something that I haven't been able to figure out in the emulator. Another big project, but that's it for this video. I really hope you enjoyed it. If you'd like to support me more directly, please head over to my Patreon. Other than that, thanks again to PCBWay for sponsoring the channel. Thank you for watching this through to completion. I am assuming that you did, and we'll see you next time.